In this video, I will show you my homemade lathe. It has a 200mm diameter chuck and a 700mm distance between centers. It can handle a maximum diameter of 280 millimeters. The machine is powered by a 370-watt three-phase motor. It is suitable for turning metal, wood, and plastic. However, its structure is a bit weak for turning iron, and sometimes it vibrates. But with light passes, you can work with iron as well, although quite slowly. The motor drives the spindle through a fixed belt transmission. It is important to use a belt drive rather than some sort of force drive to avoid possible jamming and tool breakage. Since the mechanical transmission is a single-speed fixed drive, the speed control is managed by a 3/3 frequency converter. This allows me to adjust the motor speed between 1 Hz and 40 Hz. This translates to about 8 RPM to 1500 RPM at the spindle. Torque is not as critical for such a small lathe, but at low speeds, the torque is also low. Nonetheless, it greatly simplifies usability. The machine is also equipped with a mechanical brake. The operation of the brake is indicated by a lamp. The brake can operate automatically or manually. In manual mode, the brake is continuously released and the shaft rotates freely. In automatic mode, the brake is controlled by the frequency converter, and when the motor is stationary, the spindle is braked. The cross and longitudinal axes are made from threaded rods and used linear bearings. The threaded rods are M18 with a 2.5mm pitch. Thus, one turn results in a 2.5mm cut. Unfortunately, everything works in reverse compared to factory lathes because these are right-hand threads. It was quite difficult to get used to turning everything in the opposite direction. Surprisingly, the threaded rods hold up well. However, I need to cover the mounting holes of the linear bearings because chips getting into the bearings regularly will impede their function. The tailstock was made from an old linear actuator. And finally, an unfinished feature, the electrically controlled feed. Since I need machine threading, I needed a feed. It would have been quite difficult to solve mechanically, so I chose an electric feed, thinking it would be simpler. Well, it wasn't. I have programmed 25 modes for the Arduino. These modes cover the most frequently used feed rates during turning. You can cycle through the modes using 2 buttons. When the desired mode is selected, you can activate the feed with a switch. The concept is as follows. An encoder measures the spindle rotation. An Arduino processes the encoder data and the set feed rate, and then a NEMA 23 stepper motor drives the longitudinal axis threaded rod. The feed can be adjusted between 0.01 millimeters and 5 millimeters. It can be used for threading and long turning operations. Or rather, it could be used, but complications arose. Unfortunately, fine electronics do not like to be near high-power devices. The noise pulses from the frequency converter create such interference that the Arduino and motor controller exhibit signs of demonic possession. But I won't give up. Sooner or later, it will be a functioning feature, and I hope to make a video about it. I've selected some materials needed for another video. I'll be turning plastic this time. Plastic, brass, and aluminum can be machined beautifully. As I mentioned, there are more or less problems with iron. I've made rollers for a sliding gate, pulleys, washers, centering rings, and a lot of knickknacks. If this video gets a lot of views, similar content can be expected. And if you've made it this far into the video, please give a like and subscribe. By the way, you might have noticed why I left such a large range of motion for the cross slide. In the future, I would like to build a Z-axis for it. This way, I could also use the machine for milling and as a column drill. Another major drawback of the machine is that the handles are not graduated. This makes precise work much more difficult. Hopefully, the counters I ordered from China will arrive soon, allowing me to work more accurately. I also plan to build bellows protection over the linear bearings for longer life. I know it's uncomfortable for the AI to listen, but trust me, my English would be even more uncomfortable. This year, I want to learn English and narrate my own videos. For now, I'm not quite there yet, so I'll stick with the AI. From now on, let's keep the video ASMR-like. Thank you for your attention. Let's listen to the sound of the machine and the chips instead of the terrible AI voice generator.